Hi folks, welcome to our live stream, Transforming Commercial HVAC, the Future of AI-Driven Energy Management. And it's a dive into the new research report that we published last week. So while we wait for others to join, here are some of the subjects that we're going to cover today based on this research. So we're going to go through, first of all, the introduction to the report, and also what scope, of course, like what does it actually include, what technologies are in scope, what technologies are out of scope. We're going to look at some of the drivers for the market and some of the things holding it back. We're going to take a quick look at what we think the size of this market is based on the baseline of 2023. And then also we're going to introduce a solution maturity model that we've worked on as part of the report. And then finally, I wanted to touch on one of the very interesting vertical markets in this space, and that's data centers. So we can definitely take some questions later on. We can kind of do that at the end. But also my colleague Owen, who was actually the lead researcher on this piece of work, he's in the chat. And he's will answer any questions if you have them as we go along. We're also recording the session, so you might be seeing this later on in your YouTube feed or your LinkedIn feed. If you want to go and subscribe to our YouTube channel, if you search for Smart Building Series, you'll be able to find it. Give us a subscribe because we also post like content from our podcasts and stuff up there. All right, so hopefully we've got a few more people in the stream now. Can you bring up the report page? There we go. So this is what the report looks like, and this is where the data that I'm talking about from today comes from. Specifically, right, how AI-driven energy management technologies could transform the way that HVAC systems operate. To enhance not just efficiency, but also sustainability of our commercial real estate. So, as with all research, definitions are important. So, what we considered to be in scope for this research are software solutions that directly support HVAC automation and optimization, energy performance optimization and carbon emission reduction solutions, automated HVAC fault detection and diagnostic solutions, FDD, data integration and interoperability solutions as they apply to HVAC optimization, and finally any AI-enabled occupancy-based control solutions for HVAC. What is not included in the report are sort of broader energy management systems that incorporate non-HVAC elements. Also, no energy data visualization and reporting tools, or sustainability and ESG solutions. And also no grid interactive or interaction software. And of course, no hardware revenues from energy management. This is specifically about software. We are actually going to do a report on grid interaction software and treat that as a separate piece of work. So that will be published later this year. Now, in terms of how we came up with the market sizing numbers, as I mentioned, our baseline market revenue estimate was for 2023. And we took a bottom-up approach to working out the data for this report. So we identified over 100 companies providing software that we considered in scope. And through various sources, we've estimated the proportion of their revenues that we believe are in the scope, given the definitions that I gave you earlier. And our growth forecast then for the market is based on analysis of what the drivers and what the barriers are and what the kind of global picture looks like. So let's get on with the next slide. So this infographic visualizes the flow of data that occur between different technologies that enable this kind of AI-driven technology stack. At the base of the stack lies what we've called the data acquisition layer. Basically, if you will, the central nervous system of this system. It captures real-time data from different sources and to inform the kind of decision making that is going on. And you can see there we've specified some of them, of course, like weather data, information from meters about how much electricity is being used, etc. Then what you can see up from them is once that's collected, the data enters a kind of integration and processing layer where it is prepared for analysis. And then the layer above that is this AI and machine learning optimization layer, which of course is critical to what we're talking about here, where this kind of advanced analytics is going to drive efficiency and also send specific instructions to advise the BMS or the HVAC operator for optimal system settings. And, a very obviously specific feature of this technology stack is that ability to learn and improve over time. So you can kind of see like that feedback loop going through on the left, but then the actual training, continuous model training happening there on the right in the pink. So the system updates its machine learning model with new data inputs, and that source enhances the accuracy and optimization effectiveness. So that's sort of our take on what the technology stack looks like. So specifically some of the drivers that we see, and then some of the barriers. So of course, we all know that the global energy landscape is going through a pretty significant transformation at the moment. Much like when building energy management systems came along, it can be traced back to kind of coinciding in the 70s with the global oil crisis. And, we're in a situation at the moment where global conflicts, climate change, and this transition to renewable sources are all driving a focus on energy management and efficiency. Also, within commercial real estate, there seems to be a growing emphasis on sustainability and green financing, and that's having an impact. And then also increasingly and importantly, we're seeing a stronger regulatory landscape in developed markets. So I'm thinking specifically there, Local Law 97 in the US and the Energy Performance of Buildings Directive in the EU. And we actually covered those in a podcast. If anyone's interested, we talked to the guy from the Institute for Market Transformation in the US, Cliff Majerzik, who gave some really interesting detail on those specific regulations and his view on what impact they're having. So go and check that out. It's on our YouTube channel if you're interested. But of course, it's not all pulling it in one direction. There are things that are holding the market back, and one of those is the slow rate of retrofitting and also the kind of structural complexity of these older buildings that we have. They're presenting a barrier to improving the overall energy efficiency of our building stock. And actually, if we want to align with the IEA, the International Energy Agency's net zero emissions by 2050, the scenario that they've put out, direct emissions from buildings would need to fall by something like 50% in 2030, which is only 6 years away. And quite frankly, if we want to get there, we're really going to have to pull our fingers out. But, we'll see. So this slide comes from work done by the National Taipei University of Technology. And it's a comparison or a comparative assessment of AI's energy saving potential for different smart building applications. And what they did was looked at over 164 academic papers to come up with these numbers. I actually showed this slide before, I think, in an AI live stream that we did. And, okay, so it's pretty eye-catching numbers. And I think actually what I'm take away from it, at least, is not specifically the numbers, but really the variance, right, in energy saving potential. What we're talking about today, HVAC, you can see there's massive variation in the energy saving potential. So, why is that? And I think it is because of the types of buildings that we have, their use, the age of buildings, all lead to a massive variance in what is possible. So I think it's quite difficult as a vendor, to go and promise specific energy savings to someone who has a property portfolio, and say, I'm going to save you X or 40% over your entire building stack. It's probably not the reality of the situation. It's going to be easier to save energy in certain types of buildings using this approach than it is with others. That said, in the report, we do look at some of the various successful AI optimization case studies that are out there, and they're across various verticals. So, there's definitely evidence that this approach is working. So, just a quick look at the market sizing. We've estimated that the market for this type of energy management software for HVAC optimization in commercial buildings at the baseline figure for 2023 is $3.65 billion. And by 2029, it should reach $5.83 billion. And that represents a growth rate of 8.1%. So some specifics on that. The office sector still represents the largest potential market for HVAC optimization software. Offices account for 17% of total US commercial building floor space. So it does make them a critical target for HVAC efficiency improvements. Data centers account for an outsized proportion of market revenues based on their relative to their floor space. It's stated that HVAC cooling can account for as much as 40% of a data center's total usage. So that does make efficient HVAC management pretty crucial in that respect. And I'm going to talk a little bit more about that in the last slide. Finally, the landscape, or at least the competitive landscape here in this sector, is definitely characterized by quite a few vendors. There's been a significant amount of VC funding from VCs, but also corporate investors, and also a growing number of acquisitions. So of those over 100 companies that we identified, we counted 54 of them that had secured funding. And that came to a total disclosed funding of just over $2 billion. So this is the solution maturity model that we proposed. And really just to kind of give a better understanding of where we think the market is in terms of maturity. And you can see there are basically 4 distinct layers. So tier 1 represents basic energy monitoring and rule-based control with limited automation and integration. Tier 2 introduces some semi-automated control and basically data-driven analytics, so allow for more comprehensive energy management. Tier 3 transitions to more of a data-driven optimization, which would incorporate some machine learning and predictive analytics, and it would enable more dynamic optimization based on data, predictive data. And finally, tier 4, which would sort of represent, at the moment at least, what the pinnacle, right, of HVAC energy management would look like. So where there's sort of predominantly autonomous or AI-driven systems that are capable of optimizing performance without human intervention. And based on this model, in the report, we've made some assessment of what we think the global distribution across those 4 tiers actually looks like in terms of percent of systems that are installed. So yeah, I said I just wanted to mention a little bit about data centers. It's something that is getting a lot of attention at the moment. I've seen numerous announcements from big tech companies about investments that they're making in data centers, and that is being driven by the demand for AI. Just yesterday, actually, we saw there was an announcement about US tech firms investing something like $8 billion US dollars in UK data centers. So, you know, over the last few weeks, I've seen various announcements like that. And as I previously mentioned, you know, the HVAC cooling does account for a significant amount of data center energy use. Actually, you know, this isn't a particularly new subject. Like a lot of pioneering work was done by Google DeepMind to reduce energy consumption for data center cooling using this machine learning approach. And they announced that like back in 2016. Interestingly, some of the guys from DeepMind now run a company called Phaedra. What we've seen more recently, though, is sort of Google, Microsoft start to publicly admit that because of this AI arms race, for want of a better term, they are probably going to miss their self-imposed 2030 zero emissions goals. And this, I think, sets up some kind of, you know, interesting potential AI versus climate change scenario. There's this term in economics called Jevons paradox, right? Where, so, you know, it's an old term, but in this case, is what it's saying is like the promise of AI to enable companies to do more with less, right? That's kind of like the promise of what AI will do, but the reality is it probably just will let companies do more. So as the cost of applying AI comes down, the number of AI applications goes up, and it results in significantly more, or a significant net increase in energy consumption by data centers. And whilst this is kind of like beyond the scope of research in the report, I think it's interesting to see, you know, what actually will be the overall impact of AI on total energy consumption across society. And whilst, you know, a move towards renewable energy will definitely, you know, mitigate that, I'm not sure it's going to be able to cover or solve it outright. So yeah, just a couple more slides. I wanted to say that you know, I've plugged the report. Here is the link to the website. So if you scan that, you can go to the page and check out some more details on it. Also, you know, if you want to consider subscribing to Memory, you can do that as either an individual or as an enterprise, a company. Individual subscription will get you access to all of the research notes that we write on companies on our website. So it's just things like competitive intelligence, looking at their financial analysis of public and private companies, and lots of interesting research that we do, posting stuff every week. And then for companies, the enterprise subscription, which gets you access to all of that, but also all of the reports that we write during the year, including this one. So you want more information on that, you can go to memory.com and I think click on subscribe. Great. Well, thanks for listening. And let's see if there are some questions. Give me 1 second. Let me just check LinkedIn as well. I can't see. So if you do have anything you wanted to ask about the report, or indeed, other topics that are, vaguely kind of, relevant to what we've talked about, then please do. But I will check YouTube as well, just to see if there is anything you wanted to ask. Okay. Well, I'll give you another minute or so. If anyone wanted to add a question or a comment, please do. Of course, you can. You don't have to do it now. If you want to contact us, you can do it on support@memory.com. Thanks for the comment there. I hope the content was really interesting. Okay, just a question here from John. Are there any necessary prerequisites to realizing these savings? Well, using this approach, yeah, there are. And if we go back to look at the slides, 1 second. Can we do that? There we go. Yeah, I think, obviously this kind of technology stack does rely on you, doing some of the basics, right? Like being able to acquire the data that you need to train your model, and also to do the processing and analytics that are required to train the model. And any links for patent on AI driven? And yeah, I think we did. We definitely did an analysis of patents in the report. I don't know if Owen's there. We can remember what page it is or whatever, but we did an analysis of patents. I think there was over 700 that we managed to find online. So there's a lot of work being done in this space. I think if you can go to Google Scholar and do some searches on that, you'll definitely find some. That's probably my advice for free links anyway. But again, if you wanted to buy the report, there's more information. We do like an analysis of it in that. Anyone else with a question? As I said, feel free to email us, support@memory.com. Or, on LinkedIn, you can send us a message through the report page. Thanks for those 2 questions. And thanks for joining. Again, you made it this far, so if you enjoyed the stream, please click the like button, share it with your colleagues. Appreciate it. And see you on the next one. I'll do.